This video is to run through how to use the calculator for hypotheses testing for large samples. So we're looking at the Chapter 7 Review Extra, the one that you should be using today in class. So we're just going to read through the example and talk about how we get to the calculator. So our example is, in the past, the average length of an outgoing telephone call from a business office has been 143 seconds. Manager wishes to check whether the average has decreased after the introduction of policy changes. Sample of 100 telephone calls produced with a mean of 133 seconds, standard deviation of 35. Is there enough evidence to support the manager's claim, giving you alpha is 0.01? So obviously, first thing we need to do is write our ho and our ha statement. The big part that we need is ha because we're going to need that part for our calculator. So we know all of the steps leading up to our test statistic, plugging in the values. So to get the p-value, this is where we're using the calculator. So we're going to start by looking at our calculator over here. We're going to go stat over to test. Now remember, all of your shortcuts are in here. Since it's a large sample means z-score, we're going to click z-test. The first thing it's going to ask you is whether you're dealing with data or statistics. You have literally the numbers given to you for your mean, your standard deviation. That's going to be your stats. So we're going to click that, hit enter. From there, it's just kind of filling in the blanks. So our mu in this example is the 143. Our standard deviation, again, was given to us. It's 35. X bar in this example was 133. And our sample size is the 100 telephone calls that we calculated. From here, this is where the ha statement comes into play, because we need to replicate that in our calculator so it knows what type of tail distribution. So since we said it's less than 143, we're going to click the second. Click enter until that's the only one blinking. And when we click calculate, it's going to give us a couple of different things. First and foremost, we're going to take away the z-score, which in this example we would say is negative 2.86, as you can see down here. And then the other main factor is your p-value, which you then use to make your conclusion. So in this example, our p-value would be 0.002.